Imagine you are standing at the base of a mountain. The climb looks impossible, but instead of hiking up, you step onto an escalator that carries you 900 meters straight through solid rock. It sounds impossible, but China just built it, the longest underground escalator on Earth. And the reason behind it reveals where the future of global infrastructure is really headed. Deep inside Tianmen Mountain in China's Hunan province lies an escalator unlike anything on Earth. Nearly 900 meters long, that's the length of 9 football fields, and climbing 340 meters straight through solid rock. It's taller than the Eiffel Tower, except you're moving inside the mountain, surrounded by carved stone walls. Before it existed, tourists had to climb 999 steps to reach Tianmen Cave, the stairway to heaven. Beautiful, but exhausting. So engineers chose a radical solution: go through the mountain, not around it. The result? 12 connected escalator segments built specifically for this project, stretching through a tunnel carved from 150,000 cubic meters of rock. It moves 7,000 people an hour, turning what was once a brutal climb into a smooth, half-hour ascent through darkness and stone. And that's just the beginning of what makes this system so extraordinary. Building this escalator was not just about digging a tunnel and dropping in machinery. The geological survey alone took 8 months. Engineers mapped every fault line, water pocket, and shift in rock density along the proposed route. Tianmen Mountain is made of limestone, stunning for caves, but a nightmare for builders. One section can be solid as concrete, while a few meters away, the rock crumbles like sugar drill too hard, and the mountain collapses. Excavation used a drill and blast method, but with surgical precision. Traditional blasting pulverizes rock. Here, each charge had to fracture stone without sending shockwaves through nearby caverns, some sacred, others ecologically protected. Work advanced in short sections, never more than 20 meters at a time, with immediate reinforcement. Steel mesh and high-velocity shotcrete bonded the rock. Then came waterproofing, because inside a mountain, water is constant. Without drainage, the tunnel would flood within months. And then came the real challenge: installing an escalator system in a place it was never meant to exist. Escalators are precision machines, thousands of moving parts designed for clean, climate-controlled malls. Inside a humid mountain, corrosion, temperature swings, and tight access made maintenance nearly impossible. The angle added to the chaos. Most escalators tilt about 30 degrees, Tianmen's reach nearly 40. At that slope, normal motors overheat, braking systems fail, and even handrail speed becomes unstable. German and Swiss firms partnered with Chinese manufacturers to build custom motors and reinforced steps with deeper treads for grip on steeper climbs. Getting this equipment into the mountain might have been harder than designing it. The heaviest parts, multi-ton drive motors and steel frames, couldn't be flown in or trucked up the narrow roads. Every piece had to ascend by cable car, then travel through unfinished tunnel sections on temporary rails, assembled like a puzzle underground. Some components were too big even for the cable cars, so engineers redesigned them into smaller modules that could be bolted together on site, essentially building a car in a basement where the doors are too small. Construction lasted 4 years, one longer than planned, after unexpected water pockets and collapsing cavities forced redesigns mid-tunnel. At peak, over 800 workers labored in rotating shifts, 24 hours a day. Because once you start carving through a mountain, you don't stop until it holds. Tianmen Mountain receives over 3 million visitors annually. Before the escalator, the mountain's infrastructure could not handle peak loads. On holidays, people would wait hours just to start climbing the stairs. The experience became miserable, exhausted tourists, safety risks from crowding, complaints flooding in. The Chinese government invested approximately 200 million yuan, about $30 million into this escalator system. That sounds massive until you calculate the economics. At roughly 80 yuan per ticket, and with the escalator enabling an additional 100,000 visitors per year who would not have climbed the stairs, the system pays for itself in about 8 years. After that, it's pure revenue enhancement. Tourism is a strategic industry for China's inland provinces. Coastal cities have manufacturing, trade, and finance. Provinces like Hunan need to attract visitors and investment through spectacular experiences. Tianmen Mountain was already famous, but now it has a feature that makes international headlines, a world record escalator that becomes part of the attraction itself. Here's where it gets interesting. Chinese officials defended this project as environmentally friendly. Sounds absurd, drilling through a mountain to install industrial escalators. But their logic has merit. The alternative was expanding the road network up the mountain, which would have required cutting switchbacks into the landscape, increasing vehicle traffic, and creating exhaust pollution in a nature reserve. External elevators would have been visible for miles, altering the mountain's iconic appearance. By going underground, the escalator remains invisible from outside. The mountain's silhouette stays unchanged. The natural vegetation is not disrupted. Wildlife corridors remain intact, and by eliminating the need for shuttle buses on the upper mountain roads, emissions actually decreased. The 999 steps still exist for visitors who want the traditional climb, but elderly visitors, families with young children, and people with mobility challenges now have access to Tianmen. The escalator democratized access without destroying the landscape. In Chinese infrastructure philosophy, that's a win. Tourism and infrastructure projects serve multiple purposes. They create jobs, boost regional economies, and demonstrate technical capabilities. When China builds something record-breaking, even something as specific as a mountain escalator, it signals to the world that Chinese engineering can tackle any challenge. China is not alone in building extreme infrastructure for tourism. Norway has roads through mountains with 24 hairpin turns. Switzerland has railways climbing slopes that seemed impossible a century ago. Dubai builds everything taller, faster, more extreme. But China's approach is different. Where other countries build 1 or 2 signature projects per decade, China builds dozens simultaneously. The Tianmen escalator is impressive. This strategy creates ripple effects. Chinese engineering firms gain expertise that they can export. Construction techniques developed here get refined and used on projects worldwide. Materials and equipment manufacturers scale up, driving down costs globally. The escalator industry itself is now dominated by Asian manufacturers who learned through projects exactly like this. European companies that once led the market now compete with Chinese firms that can deliver equivalent quality at lower prices because they have built more escalators in the past decade than anyone else. Walk through that tunnel escalator and you will notice something fascinating. The walls aren't just bare rock. They are lit with LED systems that change colors, creating an experience that is part journey, part light show. There is piped-in music, informational displays about the mountain's history, and air circulation systems that keep the temperature comfortable. This was not just engineering, it was experience design. The 30-minute ride could feel claustrophobic and tedious. Instead, designers turned it into an attraction within an attraction. That thinking represents a shift in infrastructure philosophy. For most of history, infrastructure was purely functional. Roads to transport goods, bridges to cross rivers, elevators to move people. Now, especially in Asia, infrastructure itself has become a destination. People visit just to experience the ride. The Tianmen escalator has its own social media hashtag. Millions of photos and videos get posted annually by visitors documenting their underground journey. That organic marketing is worth more than any advertising campaign. A few details make this project truly historic. Behind the main escalator tunnel runs a second network of service passages, letting maintenance crews reach any part of the system without ever stopping visitors, a level of foresight rarely seen and never cheap. Power reliability was treated as life-critical. The escalators draw from the main grid, but also have on-site diesel generators and battery backups, enough to keep everything running long enough to evacuate passengers safely if both primaries fail. Hundreds of sensors hidden in the walls constantly track air quality, humidity, and even tiny shifts in the mountain itself. If anything moves, engineers know instantly. All of it feeds into a central control room, banks of screens showing live video, sensor data, and passenger flow in real time. When you're carrying thousands of people through solid rock every day, there's no room for surprises. The Tianmen Mountain Escalator is more than a tourist attraction. It's proof of concept. If you can carve a 900-meter escalator through solid rock, what else becomes possible? Underground transit beneath crowded cities, pedestrian networks below the streets, access to places once thought unreachable. 20 years ago, this idea seemed impossible, too complex, too expensive, too risky. Today, it moves millions safely every year, and the same technology is now being studied for subways, mountain transport, even underground commercial districts. Because as cities grow denser and land becomes scarce, the next great frontier might not be up, it might be down. What started as a tourist project could become the blueprint for how millions of people move through cities in the future. If you think building a 900-meter escalator through a mountain is impressive, wait until you see what happens when China removes humans from the equation entirely. A 157-kilometer highway built start to finish. No drivers, no crews, no manual paving. Robots, AI, and autonomous machines working together in perfect coordination. Click watch next to see that video. And don't forget to support the channel by subscribing or checking the link below. Thanks for watching.